Alright, this is section 8.3. Now we're making inferences about still two population means. However, in this section, the two populations, the sample data is coming from matched paired. Matched paired just means that the two sample data are related. They're dependent on one another. So you could be looking at the heart rate of somebody, the heart rate of different individuals in a sample. You would take their heart rate before exercise and then their heart rate after exercise. It's coming from the same sample. It's just you're taking it at two different times. So they are related in this section. The three assumptions are that the two sample data are matched pairs. Both samples are simple random samples, and either both samples are greater than 30 or they both come from normally distributed populations. These assumptions are on page 467. And when we're working with matched paired samples, we will always be given the data values. We'll be always given the data values. So the first example that we're going to do is on page 468. Are forecast temperatures accurate? So it says data 8.2 consists of 5 actual low temperatures and corresponding low temperatures that were predicted 5 days earlier. The data consists of matched pairs because each pair of values represents the same day. The forecast temperatures appear to be very different from the actual temperatures. But is there sufficient evidence to conclude that the mean difference is not 0? The mean difference is not 0. Alright, so we're going to be using the data in the table on the top of page 469. The first thing that we need to do is write down the claim. So we're going to test the claim that there is a difference between the between the actual low temperatures and the low temperature. So if our claim is that there is a difference, that would mean that it's not equal to 0. Alright, the difference is not equal to 0. So the first thing we're going to need to do is we have to subtract these two. First thing you need to do is enter both of those, all those values into the list in your calculator. I have them entered in list 1 and list 2 of my calculator. So list 1 are those values, list 2 are the 5-day earlier values. So what I'm going to do now is I have to subtract those two values and store them in list 3. So I'm going to take list 1 minus list 2 and I'm going to store it in list 3. Hopefully you guys remember how to do that. So we're going to hit second 1, list 1, minus second 2, hit enter. Those are the differences between those the two sets of values, and we're going to store them. Here's store in list 3. Alright, so now those values are stored in list 3, and to test the claim we're going to use t-test. When you're testing the claim about matched pairs, you're going to use t-test. You're going to use the values in list 3 for that t-test. So you're going to use the data option in t-test. You're testing the claim about matched pairs, and then we're going to use the list 3 data values. So let's scoot this over just a little bit. So we have list 1 minus list 2 stored in list 3. This was our original claim. The opposite would be that the difference between the means is 0. The difference between the means is 0. Our claim is that there is a difference, so that means that the difference between the two is not 0. This is the alternative hypothesis, null hypothesis. Alright, so we go to our calculator, stat, tests, t-test. We're going to enter the data values, or use the data values. The value of the null hypothesis is 0, and the difference between those two data values is in list 3. So we want to use list 3. We subtracted the two lists, stored them in list 3. That's the list that we want to use. And our alternative hypothesis is not equal to, so we hit calculate. There's our test statistic and p-value, negative 2.76. Negative 2.76. P-value is 0.0507. Alright, so now we want to compare our p-value to the significance level. Significance level is 0.05, and it is slightly higher than the significance level, so we are going to fail to reject the null hypothesis. Sorry, slightly higher, so fail to reject the null hypothesis. Now we can state our formal conclusion. Since we failed to reject the null hypothesis, there is not sufficient evidence to our original claim was the alternative hypothesis support the claim that there is a difference between the two means. Alright, and lastly is the critical value. It's a t distribution, so we're going to use t interval to find the critical value. Stat, test, t interval is 8. And we're going to enter the stats. When we're trying to find a critical value, we should have 0 for the sample mean. And for the sample standard deviation, we're going to use the square root of the sample size. Let's see, there's 5 values in the sample. Both samples have a sample size of 5, so we're going to use the square root of 5. Sample size is 5. Confidence level, it's in both tails, so we want to use 1 minus 0.05, 0.95, and calculate. So we have positive and negative 2.77. Alright, all finished with that part of the problem. And then so now we tested the claim. Now we want to just construct the confidence interval for that same problem, that same example. So same example, same values. So we're going to construct the confidence interval, and so we're going to use t interval. We're doing the example on the bottom of page 470. So we're using a 95% confidence level. Same values. Again, we're going to use t interval, stat, test, t interval. Now we're going to use the data values in list 3. We already subtracted the two lists and stored them in list 3. Confidence level we're using is 0.95. Hit calculate, and we're done. Here's our confidence interval. We're going to round it one place to the right of our data value. So negative 26.5 to 0.07. Alright, so we are 95% confident that the interval from negative 26.5 to 0.07 contains the true difference between those population means. Alright.